Bismillahirrahmanirrahim. Welcome to Beingguruelectrical channel. This is Mujib with you with interview question answer series number 2. So today we have 15 questions interview series. So watch the video till the end. So you should not miss any of the question. Before going to start the video, if you are new on the channel, so hit the subscribe button and turn on the notification by clicking the bell icon. So now let's start our today series 2. So the first question is, in the ceiling fan, if we reduce the feed span through the dimmer switch, so what will the impact on the power consumption? Either it will decrease or it will remain same. So slowing speed means we are adding the resistance in the series of the line. So slowing speed means increasing resistance, therefore cause less energy or power consumption. So what does it mean? If we are reducing this fan speed, what it means that we are limiting the current. So if we are limiting the current, it causes less energy to be consumed, so hence our power consumption will be low. Now the second question we have, what if the kVAR is removed from transmission system? There are a lot of misconception about the transmission system, that we have kVAR about 10% or 15% in some countries or in some states. So why we need this 15% or 10% kVAR? However, we can remove this kVAR by increasing the kilowatt or by increasing our power factor from 0.9 or 0.85 to 0.98 or 0.99, but we are not doing. So what's the reason? So let's see. Transmission lines and transformer and other inductive load need kVAR for the proper operation. In the transmission system, even the substation and all the transmission lines, we have inductive loads. So these inductive loads need kVAR power, which is the reactive power, for the proper functioning. So if we eliminate kVAR, it would stop inductive equipment from working, because we have a transformer which is working on the inductive, which is working on the induction. So if we remove completely the kVAR, so our induction equipment will stop working. So it is also required for the proper functioning of our system. So that's why there is always some power of kVAR in the system. This kVAR is produced from the powerhouse, synchronous generators. Now next we have question number 3. Can transformer work on DC? So let's see. Anyhow, the transformer is an AC operating device. So applying DC to transformer, what will happen? It will give output from 0 up to the maximum DC value, because from 0 to DC value it is changing. So for the change, the transformer will give output. After the maximum DC value reach, transformer output will be vanished. So transformer required alternating current to operate only. This is the AC operating device, so it only operates on AC, not on DC. Next question we have question number 4. What is mean by service factor of motor? This is a very important question in the interviews. If you are going to the industries, you may be asked about this question, the service factor of motor. What does it mean? What is this for? So if you see the nameplate, you can find here the power at this voltage, this current, RPM, SF. SF means the service factor, which is 1 here. So what does it mean? So let's see. Service factor is the percentage of overloading the motor can handle for short periods. So what the service factor is? It is the overloading percentage which the motor can handle. So in this case we have 1. So this cannot handle the overload. It should be operated until 100% of the capacity. Above 100% it should not be subject to overload. Okay, when service factor is the percentage of overloading the motor can handle for short period when operating normally within the correct voltage tolerances. Within the same voltage range or tolerance, the service factor allow you to overload your motor for a short period. So this is the service factor. Now consider another example. Consider a 10 HP motor with a 1.15 service factor. So this motor can provide 11.5 HP. Even this is 10 HP, but it can provide 11.5 HP when required for short-term use. So this is service sector. In this example, we have 15% overload capacity. We can use this for the short period. Limitation of Ohm law. Question number 5. Ohm law is applicable to linear circuits only. It is not applicable to non-linear circuits. Question number 6. Why motor is rated in kilowatt and not in kVA? In the previous series, we talk about the transformer, why its rating is in the kVA and not in kilowatt. Today we'll see why the motor rating is in kilowatt and not in kVA. So let's see. Motor has resistive consumption. Motor has resistive consumption and it needs kilowatts. So we take kilowatt is the rating of the motor. It also takes kVAR from the system, and which is compensated by capacitor. But this kVAR is not used. It moves to and from in the system. It is not usable. The kilowatt is using by the motor, so that's why the motor rating is taken kilowatt. What is the difference between circuit breaker and isolator? You can see in the picture we have isolator and this is circuit breaker. So circuit breaker is used for on load operation and off load operation. So circuit breaker is used for both on load and off load operation. However, isolator is used only for off load operations and has arc quenching medium. It has an arc quenching medium. The arc quenching medium may be SF6 gas, it may be air, it may be vacuum, anything. But isolator has only air as in quenching medium. Okay, it protects circuit breaker under fault and operate automatically. Circuit breaker operate automatically under fault condition while isolator operate not manually during maintenance. So isolator is operating at no load as we discussed, and it has air as arc quenching medium. It is mainly operated for maintenance purpose only. It's already discussed. So next we have question number 8. What is the difference between MCB and MCCB? This is a very important question for the engineers to understand this. MCB is non-adjustable. This is MCB. This is MCCB. So MCB is non-adjustable. We cannot adjust this rating. It is used in low current application. You can see this in the distribution board in the home, apartment, residential complex, or even in industry for the lighting protection, power sockets like this. You can see the MCB protection, and its rating is up to 100 ampere in commercial and residential distribution boards, while MCCB are adjustable. These MCCB are adjustable. You can see this blue circle over here. It is for adjustment. So MCB are adjustable. You can adjust the current rating of this and used for protection of equipments. This is mainly used for the equipments in commercial and industrial application. It is available in rating up to 3200 ampere. This is available in very high rating, 3200 amperes, up to and maybe more, with the breaking capacity up to 200 kiloamperes. This is available in breaking capacity up to 200 kiloamperes. But this is I think normally available up to 35 kiloampere, and this is up to 200 kiloampere. So that's the difference between MCB and MCCB. Next we have what is the difference between earthing and grounding. This is a very common asked question in the interviews. So let's see. You can see here earthing connected to the earth bus bar. Here we have grounding. So grounding means connecting neutral to earth. Here we have neutral connection directly to earth. This is called grounding. This is called system grounding. And earthing is used for personal safety. This earthing is used for the equipment to remove static charges from equipment bodies. For this equipment body is connected to earth. These cables are coming from the equipment bodies. So if any voltage is there on the equipment board, it will not harm the human or the personnel. So it is used for the personal safety only. Next question number 10 we have what is the difference between ELCB and RCCB. ELCB and RCCB. Let's see what's the difference. Here you can see this is RCCB. This is Schneider brand and this is Schneider brand ELCB. ELCB is voltage operated. and RCCB is current operated. This is the main difference between the ELCB and RCCB. But now ELCB is not commonly used, it is replaced by RCCB. Okay, ELCB is voltage operated and operate only if leakage goes to main earth. ELCB only operate if the leakage goes to the main earth. In any case, if the equipment is not touching the earth, this ELCB will not operate because the leakage is not going to the earth. But in the RCCB, because this is ELCB is operating on the voltage. Okay, RCCB is current operated and operated at any earth fault, and it work on the at the input, it see the line in neutral, and if both are equal, it will work. If there is any slight difference between the line and the returning neutral current, it will trip. Let's see an example: equipment having earth fault but having not contact with the ground, as we discussed. For this scenario, RCCB will trip but ELCB will not. So now in many application, RCCB is used and the ELCB is replaced by the RCCB. Now next question we have question 11. What is the placement of winding in transformer? How the winding are placed in the transformer? We have two windings normally in the transformer, which is high voltage winding or in low voltage winding, primary and secondary. So high voltage winding is always outer. You can see in the picture, the one we are seeing is high voltage winding, and inside the high voltage winding we have low voltage winding. So this is the placement of winding inside the transformer. Question number 12, we have MCB and RCCB can be used combinedly, because it's also important question. So we can use both, or only one can work for some application. So MCB and RCCB can be used combined. And also now one latest advancement, RCBO, residual current breaker with overload. So this provide RCCB operation, and the overload operation is provided by the MCB. So if you want to use MCB and RCCB combined in one application, it's better to use RCBO. It will provide protection for the MCB and the RCCB. So RCBO is now available, which is residual current breaker with overload protection. So it works as MCB combined with MCB. This is the RCBO. Okay, next question 13. Arc quenching media in circuit breaker depends on what? Okay, already we know there are different quenching media in the circuit breaker. It may be SF6, it may be air blast, it may be vacuum. So let's see what it depends. So arc quenching media in breaker depends on voltage. If for the low voltage or LV breaker, we used air as the quenching media, but in medium voltage we use vacuum as the arc quenching medium. In the high voltage we use SF6 gas as the arc quenching medium. High voltage there are some oil circuit breaker, but now this is replaced by SF6 gas. Okay, question 14 we have, what is dangerous, AC or DC? So DC is more dangerous compared to AC. Why? Because the frequency is 50. So AC cross 0 50 times in 1 second. So at 0 crossing, because when the human body is subject to electric shock, so due to the reflexes, if at the 0 crossing, it is the probability that it will leave the human body. So it can be saved in the AC, but in DC, which is all time high, so there is less chance to be saved from the electric shock. Question 15 we have, why welding machine doesn't give electric shock? So let's see, this is the welding machine. So voltage, which is 12 volt or 24 volt, normally too low to overcome human skin resistance. Human skin resistance start from 500 kilo ohm to up to 10 mega ohm. This differ from human body to human body. So this 12 volt or 24 volt is normally too low to overcome human skin resistance. So even 250 ampere and 300 ampere, this one is providing 200 ampere and this one 300 ampere. So it's not giving shock to human body at 24 volt. So due to the low voltage, it is not giving any electric shock to the human body because the voltage is very low. So this is the end of the today's session series 2. If you have any question, do let us know in the comment section, and if you like the video, like it and share with your friends. And if you have any question, so you can put in the comment box to include in the next series 3. Thank you.